Hey guys, and welcome to density and buoyancy. So in this lesson, we're going to be talking about mass and volume. We're going to ask what is density. There's our density equation we're going to use. We're going to use that equation to solve density problems. We're going to talk about Archimedes, buoyancy, some application, and then we have some practice problems to finish it off. So first of all, how does your lesson work? Well, everything that is bolded and underlined on this video is a blank in your student copy. So when you see any text that is bolded and underlined, make sure you fill it in on your copy. Just pause the video, fill in the text, and then continue on. Additionally, whenever you see a video, you'll be able to find that video in the additional resource file. So simply go to the additional resource file, watch the video, and then while you're watching the video, make sure you take notes, because the videos are there to supplement the material. Okay, they complement the material well, and they will help increase your understanding. So first, let's recall a few things. So density is a property of matter. This means that all matter has a specific density that is different from the density of a different type of matter. So for instance, lead has a density, gold has a different density. Based on what has been discussed before, describe the relationship between mass, volume, and density. Well, bricks, for instance, have a lot of stuff per volume. Okay, they may not take up a lot of space, but they feel heavy, as we like to say. So we like to say that bricks have a very high density. They have a lot of stuff in a very small container. Sponges, on the other hand, have less stuff in a given container. So if you have a brick and a sponge that are the same size, the brick is going to feel heavier because there's more stuff packed in. Okay, we say the sponge has low density. Now this brings up the question of which is heavier, a kilogram of feathers or a kilogram of lead. Well, they both have a mass of 1 kilogram, so they weigh exactly the same. But the lead is much more dense. You can pack a kilogram of lead into a much smaller space than you can a kilogram of feathers. So let's take a recall of mass. So mass is a physical property that represents the amount of matter, stuff, an object contains. We measure this in various quantities, but specifically we're going to use grams and kilograms in this lesson. Volume is another physical property. This represents the amount of space an object takes up. It's measured in things like milliliters, liters, centimeters cubed, etc. Now density is another physical property, and it's a measure of how close the particles in a substance are. Okay? Essentially, how much stuff can we fit into a container? Okay, so which container is more dense? So the container on the left or the container on the right? Well, if we can count all the different particles inside the containers, we'll know that the left, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 particles in the left, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 on the right. So in the exact same volume, right, the volumes are equal to each other, but there are more particles on the right than on the left. Okay, so we would say that the density is higher here, okay, because there's more particles per given area. So if you have two objects, say iron and wood, of the same size, which will feel heavier and why? Well, the iron will feel heavier because it has more stuff squeezed into the same volume. Both objects have the same volume, but the particles inside the iron are much closer together. You can see that in this diagram here. The particles are much closer together, therefore we can pack more into the same area. Now we have a formula for this. There's a couple ways you can remember it. There's just the general formula, or you can use this triangle here. Now the way the triangle works is pretty simple, right? If you're trying to find mass, okay, you simply cover up mass and you're left with density times volume. Okay, if they're left and right, then it's multiplication. If you're looking for volume, we're going to cover up volume and we're left with mass divided by density. And then similarly, if we're looking for density, we're going to cover up density and we're left with mass divided by volume. Okay, so see how that works? So you can use the triangle. It's very useful, or you can simply remember density equals mass over volume, and then you can rearrange in two different ways, right? We could also write that formula as V equals M over D, and we can rearrange to say that m equals d times v. So different ways to do the exact same thing. Now we have components of density, which we've already talked about. We have mass, we have volume, and we have density. Mass is described as the amount of material of an object. We measure it in grams, kilograms, and we're generally going to use a balance to figure this out. Volume is the amount of space the object takes up, and density is the amount of matter per volume. Okay, and we're going to measure that in a mass unit over a volume unit. So if, for instance, grams over milliliters, or grams over cubic centimeters, or grams over liters, etc. Now to solve density problems, we're going to use the guess method. The guess method stands for givens, unknown, equation, substitute, solve, and statement. So let's try this one. So what is the density of a, so density is the unknown, right? Of a 5 kilogram cube, so that's the mass, with one side having a length of 2 centimeters. Well, a cube, right, it's going to be 2 times 2 times 2, so that's going to equal to 8. So that's our volume. We're going to write the equation, d equals m over v. We're going to substitute our values in. We're going to solve, and we're going to write our therefore statement. So therefore, the density of the cube is 0.63 grams per centimeters cubed. Now, the volume formulas, to figure out what the volume is, sometimes it's easy, like a cube, rectangular prism, these things we know. Other irregularly shaped objects and formulas that you need, you'll also be given. Okay, so that's going to bring us to the genius of Archimedes, because when you're trying to find the volume of something, for instance, a crown, which is what he used, crowns are strangely shaped, right? They're not a box. They're going to be something like that, right? So it's going to take up a different kind of space. So we need to take that into account. So how do we find out the volume of something like a crown? A little harder. So Archimedes was a famous Greek mathematician, okay? So much of his fame comes from his relationship with Hero, who was the king of Syracuse, okay? As he performed a ton of mathematical favors and scientific endeavors on his behalf. The most famous of these is the idea of the gold crown and figuring out the density of a gold crown, which would be very difficult to figure out given the fact that a crown is a very irregularly shaped object. So watch this video, take some notes, and then we'll come back to it.